Hello everyone, how is it going? Welcome to part 4 of Computer Network Fundamentals. My name is Ahmed Inaya, and in this video I will talk about IP address, subnet mask, and gateway. In last video we talked about IP address, and we said that IP address is a 32 digits or bits, and it is in binary format. This IP address is IP version 4, which is the common IP address used currently. So this is a 32-bit binary. And we said in last video that these 32 bits are divided into groups of 8 bits each, or we call them bytes or octets. So this is one octet, for example, and this is another octet, and the other two are also another 2 octets. So 32 bits are divided into 4 octets or 4 bytes, 8 bits each. And to make it easy for humans to describe or to read IP addresses, they are usually represented as dotted decimal notation or DDN, and they are represented in this format. So this octet is 10, this octet is another 10, and this is 1 and 1. So for example, in this drawing, we have 2 networks. This is one network, and this is another network. We have 3 hosts in each network, and we described in previous video that devices in the same network can communicate directly, while devices in different networks need to communicate through gateways. So the question from any device in the network is, which IP addresses are in my network and which IP addresses are not in my network? And this leads to the concept of subnet mask, which is an important concept in understanding IP addresses, IP networks, and routing. So what is a subnet mask? Subnet mask divides IP addresses into 2 parts. One part is network or subnet, and the other part is host. Subnet mask has the same length as IP address, which is 32 bits of ones and zeros, and it always starts from the left with ones, then zeros. So the ones represent network part, zeros represent host part, and ones in subnet mask must be always contiguous and they must start from the left. So devices share the same network part are in the same network. To clarify this more, let's take an example. This is an IP address 10.10.1.1. We always start by converting this into binary, mainly because computers understand binary only. The decimal representation is only for humans to be able to read and memorize IP addresses, but computers understand only binary format. So if you convert this 10.10.1.1 into binary, we will get this format. So this is 10 in binary, this is another 10 in binary, this is 1 in binary, and this is another 1 in binary. So we have the binary format for that IP address. Let's assume this is the subnet mask. As we described in the previous slide, subnet mask must start from the left with ones, and these ones should be contiguous. Ones represent network and zeros represent host. So if we applied the concepts we discussed in the previous slide, we have 8 bits network and 24 bits host in this IP address, which means these 8 bits here are network and the rest of the IP address, which are 24 bits, are host. So let's apply this mask into the IP address we have here. We start by applying it into binary format. So this part of our IP address is network, and this part of our IP address is host. Anything in this side represent the network, and anything in this side represent the host. So if we apply this into decimal format, this means 10 is the network part, and the rest of IP address is host part. Let's take this IP address as an example. This IP address 10.12.1.5, it has the same network part as this IP address, which means these 2 IP addresses share the same network and they can communicate directly without a gateway. What about this IP address 10.66.3.1? It shares the same network part with our IP address, which means they are in the same network. But if you look into this IP address 12.10.1.2, the network part is different than the network part of our IP address, which means this IP address is in different network. This example was easy because network mask stopped at the end of the octet, which makes mapping network part and host part into decimal representation is easy. If we stop at bit 8 or 16 or 24, This makes network part very easy to represent in decimal format because we know that 8 is here, 16 is here, 24 is here, and the end is 32. Let's take another example where subnet mask doesn't fit into the boundary between octets. So for example, let's take the same IP address 10.10.1.1 and let's start by converting it into binary. Now let's have the subnet mask of 10 bits, which means this part here is network and this part here is host. For any IP address to be in the same network as this IP address, they should share exactly the same network part. So this part should be the same as this binary format for the other IP address to be in the same network as this IP address. And if you follow the same exact process, so we have 10 bits as network, 22 bits as host. And if you map this into subnet mask, the all ones are network part, zeros are host part. And if you map this into the binary format, this part is network part and this part is host part. Now, if we try to map this into decimal format, we know that this digit is part of network part. We know that these two digits are part of host part, but this digit here is divided between network and host, which makes it difficult to understand the boundary between network part and host part by looking into decimal format only. In this case, we must convert the IP address from decimal into binary format to be able to understand if the other IP address is part of the same network or not. By looking into this octet, we can see that the first two digits must be 0. This means this octet can be anything from 0 to 63 for the other IP address to be in the same network, while if this octet is more than 64 decimal, this means the IP address is in different network. So for this IP address 10.12.1.5, this IP address has the same first decimal as our IP address, so it can be part of the same network. By looking into the second decimal or the second octet, it shares the same first two bits of our IP address, which means it is within the same network as this IP address. But if you look into this IP address, 1066.3.1, and if we try to do the same calculation, this IP address has the same first decimal, but second decimal is 66, which means this bit here is 1. So this IP address is in different network than our IP address. Now, if we look into this IP address 12.10.1.2, this is much easier because the first decimal is different than ours, which means this IP address for sure is in different network. If you want to understand this more, or if you want to do the details of this, it is difficult to read subnet mask in binary format. So it is difficult to say 1111000000 for 32 bits. So similar to IP addresses, we can read them using dotted decimal notation, DDN, which means this subnet mask here can be read as 255.0.0.0, which is the same way we read IP addresses. The same thing for this subnet mask, we can read it as 255.192.0.0. So this is the same way we read IP addresses. And to make it easy, we can use this table to convert each octet into decimal format. If it is all 0, this is 0. If it is only 1 here, it is 128. If it is 1, it is 192, and so on. We have only these 9 options because the ones should be contiguous, which means we cannot have one in the middle anywhere here. Ones should be all contiguous and they should be in the left. So we end up with these options only for each octet. Now this format is a little bit long and they came up with another format which is much easier to read. As we discussed before, the ones are always starting from the left and they are contiguous, which means it is enough for us to describe how many ones we have in the left. So for example, here we have 8 ones to the left, which means the other 24 bits are all zeros and they are host. The same applies here. If we know that subnet mask is 10 digits only, we can conclude that these 10 digits are to the left and they are all 1, and the other 22 digits are host part. Let's look again into the two examples we discussed in the previous slides. So this IP address here, 10.10.1.1 with 8 bits network mask, can be represented in this format if we want to read it using DDN format the same way we read IP addresses. So it is 10.10.1.1 with subnet mask of 255.0.0.0. And if we want to read the same IP address using a prefix format, we can read it as 10.10.1.1/8. Let's look into the other example which is 10.10.1.1, but this time the subnet mask is 10 bits. So this IP address can be read as 10.10.1.1 and subnet mask 255.192.0.0. Or we can simply say the IP address is 10.10.1.1/10. So after we discussed IP address and subnet mask, we need to discuss the gateway. So what is a gateway? For two devices in two different networks to communicate, the traffic must go through a gateway. Every network should have a gateway for devices in this network to communicate with devices in other networks, and each device in the network should know the gateway IP address to be able to communicate with devices in other networks. And this gateway IP address should be in the same network as host IP address for the host to be able to communicate with this gateway. Let's assume we have two networks connected to the internet, and we have router A, which is the gateway for network A, and router B, which is the gateway for network B. And let's assume these are the IP addresses in this network, and let's assume the subnet mask is /8, just to make it easy to understand this example. So this network here is 10.0.0.0/8, which means anything starts by 10 is part of this network. And this network here is 12.0.0.0/8, which means anything starts by 12 is in this network. Let's take two examples. If this device here, 10.10.1.1, wants to communicate with this device here, 10.10.1.3, they share the same network, which is 10, and they can communicate directly without going through any gateway because they have the same network part. Now let's assume host number 2 in network 10 wants to communicate with host number 2 in network 12. So how traffic will go in this scenario? First of all, these devices are in different network because they have different network part. This one is 10 and this one is 12. So traffic must go through a gateway. So this device here should send the traffic into its own gateway, which is in the same network. Then this gateway should communicate with the other gateway, router B, which is the gateway for network 12. And then this gateway will communicate directly with host 2 in network 12. So this is the way devices use to decide network part and host part of their IP addresses, and they use this information to decide if traffic should go directly into the other device or if it must go through a gateway. Now, if you have your device connected to the internet or any IP network, how can you find your IP address, your subnet mask, and gateway? Every operating system has a way to read IP addresses. For example, if you have Windows 10, you can go to Command Prompt from Start menu, and then when you open Command Prompt, just type the command ipconfig to get your IP address, your subnet mask, and your gateway. So after understanding IP address, subnet mask, and gateway, we will discuss in the next video how devices in the same network communicate in details. We will discuss the concept of MAC address, we will discuss Address Resolution Protocol or ARP, and we will discuss unicast, multicast, and broadcast. All this will be discussed in the next part, which is part 5. If you enjoyed this video, please like, share, and subscribe to get my other videos. Thank you and have a good day.